Hello students, in today's class we will discuss LR parsers. Okay, so normally the parsers are of two types. The parsers are of two categories. One is the top-down parsers and another category is bottom-up parsers. Okay, so the LR parsers will fall under the category of bottom-up parsers. Okay, so these LR parsers we also called as SR parsers. That means shift reduce parsers. Okay, so these LR parsers are again four types: LR0, SLR1, LALR1 and CLR1. Okay, so the LR0 is the least powerful parser and the CLR1 is most powerful parser. Okay, now this LR parser means L stands for leftmost derivation and R stands for reverse of rightmost derivation. Okay, sorry, L stands for we are going to parse the input from left to right, and R stands for reverse of rightmost derivation. Okay, now all parsers, if you see, there are four different parsers are there under the category of LR parsers. So all four parsers are similar only. All four parsers will contain four components. Okay, one is stack, input buffer, LR parsing algorithm and LR parsing table. Okay, so among these four components, these three components, that is input stack, the stack and the input buffer and the LR parsing algorithm, will be same for all four parsers. Okay, these four parsers are going to differ only with LR parsing table. The construction of LR parsing table will be only different for these four parsers. Okay, means the algorithm is same except the parsing table. Okay, one more important point that we need to understand here is LR0 and SLR1 will use LR0 items. We will see what is an item later. Okay, so LR0 and SLR1 will use LR0 items, whereas LALR1 and CLR1 will use LR1 items. Okay, now we will see, first we will construct LR0 parser by taking one example. Before we see the example, let us understand what is an item means. The definition of item is any production with a dot in the right hand side is called an item. Okay, or LR0 item means any production in the grammar with a dot in the right hand side is called an item or LR0 item. For example, if you see here, S implies AA. The dot is in the leftmost position. That means I did not read any of the input buffer, any of the input as of now. Okay, if the dot is after A, that means I have read the symbol A, still I need to read the one more A. If the dot is in the last position, that means I have read the complete input, I have reached the end of the input. Okay, means this dot will gives a status or the situation about how far we have read the input in the grammar. Okay, once we reaches the last position, this AA can be reduced to S. Okay, this AA can be reduced to S. Okay, so I repeat again, the LR0 item is nothing but, whereas here if you see here, as we have seen, LR0 and SLR1 will use LR0, whereas LALR1 and CLR1 will use LR1 items. What is LR0 item? Any production with a dot in the right hand side is called an LR0 item. This dot is going to move from one place to the another place. Okay, now we will take one example and see how to construct a parsing table, LR0 parsing table. Now this is an example. I want to construct an LR0 parsing table. For this example I want to construct a parsing table. So S implies AA and A implies small a followed by capital A, or A implies B. Okay. So one more thing that we should do is, for this particular grammar we should add an augmented production. That means S dash start symbol dash implies start symbol. This is nothing but augmented production. Okay, is nothing but augmented production. When I add this augmented production to the existing grammar, the grammar becomes augmented grammar. A implies small a capital A implies B. Okay, this whole together we call it as augmented grammar. Okay, what is an augmented production? So start symbol dash S dash implies yes is nothing but augmented production. Now we will see how to construct the parsing table. Step 1. Now we should take first production. LR0 item. That is S dash. First production, that is S dash. The dot is in the leftmost position. S dash implies dot S. Okay. So when I take a production like this is nothing but LR0 item. Now what I should do is, if the dot is exist before the non-terminal, I should add the productions of this particular non-terminal. I repeat, if this dot appears before the non-terminal, I should add the corresponding non-terminal productions to this grammar. Okay, in the step 1 what we should do? We should take the augmented productions LR0 item. After that, if dot is followed by a non-terminal, this particular production I need to take. So what is the production of S here? S implies AA. This I should take. S implies dot AA. Okay. Now if you see here, again the dot is followed by a non-terminal A. Okay. So I should add the productions of this particular non-terminal again. So what are the productions here? There are two productions for A. A implies small a, capital A implies B. So A implies dot small a, capital A. Okay. A implies dot B. Okay. This is the first step. This is nothing but closure. Okay. This we call it as a closure. So if you see here, first of all I have added the augmented production with a dot, and I have added the corresponding productions of the non-terminal, which is followed by the dot, immediately followed by the dot. Okay. These are the productions I got it. S implies dot AA. Here again the dot is followed by after dot A is following. So I have added the corresponding productions of A, that is A implies small a, capital A implies small b. Why I cannot move further? Because after dot small a is following, which is a terminal. Here also after the dot small b is following, which I cannot add any more productions further, because I have only two terminals. I have only two non-terminals, that is S and A. Okay. For the terminals we should not have any productions. That's why I should stop here. This is the first step. It is nothing but a closure. Okay. Now we will see what is step 2. Now listen carefully. In step 2, this is the closure which we got in the first step, right? So this is the closure. Now we should apply go to in the second step. That means we are going to move the dot from one position to the another position. We are moving the dot from existing position to the next position. So I am naming this state as I naught, or I0. Okay, so this is the I0 state. Now see the first production, the dot is here. If I move the dot from here to here, this dot will move after the S. Okay, upon reading the symbol S, S dash implies S followed by dot. Okay, this I will call it as I1. Listen carefully, very important this step. Okay, we are applying now go to. In the first step we have applied the closure, now we are applying go to. Okay, upon reading S, the dot is moving from here to here. Okay, now see here, second production. If I take the second production, if I move the dot from here to here, upon reading A, symbol A, okay, S implies A dot A. Apply the rules, the same rule that which we have applied in the first step, that is A dot A. Now again, forget about the remaining two productions, we will see later. Okay, just I have read the A, because I have read the A, the dot will move from here to here. Again after the dot, a non-terminal is following. So I should add the corresponding productions of this non-terminal, that is A implies dot A, capital A implies dot B. Okay, A implies dot B. I cannot add any further productions because these are nothing but just the small letters. Okay, small letters, we should not have any productions. The terminals will not have any productions. I will call this as I2. Okay, now coming to this, S implies dot A, capital A. Now this time I am reading small a. Okay, A implies, sorry, this is A, because the productions of A here, right? Now A implies this dot will move from here to here, right? So A dot capital A. Now if you see, dot is following by non-terminal. I should add the corresponding productions of A, that is small a, capital A implies dot B. Okay, just correct this closure. In the first step also I need to correct it. Okay, I forgot to, first step I have done correctly only, A implies dot A, capital B. Now see, so now I have read the symbol small a. This is the production which I got. Okay, now this is the state I3. Now the last production, that is B. Okay, so read the symbol B, then the dot moves from here to here. Okay, so I4. One level is completed. I have moved the dot from one position to the another position. For each production I got, for 4 productions I got 4 different states. Okay, 4 different states. Now this is the first level. In the second level, again check each state, that is I1. What is the result of this one is S dash implies S dot. So here I cannot move this dot further because this is in the last position. Okay, leave this. This is nothing but final item. If the dot appears at the rightmost position of a production, that is called a final item. Okay, now come here. So take the first production again. The dot moves from here to here. Now upon reading capital A, now I am reading this, I am moving this dot from here to here. So capital A, S implies AA dot. So last one is I4. Okay, this is I4. Next one is I5. Name this as I5. Okay, now coming to the second production, A implies small a, capital A. If I move this dot from here to here, what happens? Now we will see. see here, if I move this dot from here to here, what happens? S implies, sorry, A implies A dot A dot A, right? So, because of this dot is following by capital A, I should add the corresponding productions of A. A implies small b. Okay, this is what I will get if I apply small a here, right? Isn't it or not? If I apply small a here, this is the state I got. But if you observe I3 and this new state both are equal. I3 and the new state both are equal. So I cannot have a separate state like this. Upon reading A, if I directly converted, if I directly divert this to I3, okay, upon reading A, small a, the position goes to I3, because this is what the states I got after reading A. Okay, this one is completed. Second production is completed. Now coming to the third one. A implies dot B. If I read B, if I move this dot from here to here, this becomes A implies B dot. A implies B dot. If you see here, A implies B dot is already existing. So here, upon reading B, I can go to directly I4. Okay, I2 is completed. All three productions I have traversed. Coming to the I3 again. Coming to the I3. First production. Move the dot from here to here upon reading the symbol capital A. Okay, so capital A. If I read the capital A, this becomes A implies A capital A dash dot. A capital A dot. Okay, so I5, this is I5. Now I name this as I6. Okay, coming to the second one, A implies dot small a capital A. The same situation arising here also. Here also A implies small a capital A. If I move this from here to here, this is the same state I will get. Okay, if I move small a, if I read the small a symbol, the dot will move from here to here, that is A dot A. So I should have the corresponding productions of A. This becomes A implies dot A capital A implies dot B, which is nothing but same state. Both are same states. So instead of having a separate state, okay, upon reading the small a, I will again go to the same state, that is I3. Okay, so this is nothing but a loop. Okay, this is nothing but a loop. Now if you see here the last production, that is A implies dot B. A implies dot B. If I move dot from here to here, I will reach here. So read the B, read small b, you will go to here to here. Okay, now if you observe the new states in this second level, I got only I5 and I6. I cannot move further here because the dot is appearing at the last positions. Okay, this is nothing but final items. These are nothing but final items. So this is step 2. Okay, if you observe here, any states I1, I cannot move further. I2 done. I5, I6 and I4, all are final states. I cannot move further. Okay, so in the first step we have applied a closure. In the second step we have applied what? Go to. Okay, this is a resultant. Now the last one, step 3, is constructing the LR0 parsing table, which is very important. Now we see how to construct the LR parsing table, LR0 parsing table, which is a crucial one. Okay, so in the second step, we got this DFT diagram, right? How many states are there here? There are 6 states are there. Okay, sorry, 7 states are there. Starts with I0 and ends with I6. Okay, ends with I6. 1, 2, 3, 4, 5, 6 and 7 states. Okay, so these 7 states are nothing but 7 rows. So now we will draw the diagram. We will draw the table with 7 rows as starts with a 0, 1, 2, 3, 4, 5 and 6. Okay, 7 rows are there, and also it contains two columns. It contains two columns. One is action column. Okay, another one is go to column. Another one is go to column. The action column contains all the terminals in the grammar. So now if you observe here, the grammar contains A and B as a terminals, A and B as a terminals, and also dollar by default, because dollar represents the end of the input string. And the terminals are, and the non-terminals are S and A. S and A. So the terminals are 3, that is A, B and dollar. Okay, and go to will contains the non-terminals, that is capital A and capital S. Okay, now we will construct the LR parsing table by using the DFD, data flow diagram, which we got in the step 2. Okay, now if you see here, in I0, which is 0 state, upon reading the symbol S, it is moving to I1. Okay, so I0 is a state where it moves, reads the symbol non-terminal S, moving to I1. So under capital S, write I1. 1 represents I1. Now next one is I0 after reading capital A, moving to I2. So under capital A, write 2, which represents state 2. Now from I0, 4 edges are leaving, first 2 completed, and the third one is small a. It is moving to I3. So as I have told you already, LR parsers are also called as SR parsers. S stands for shift, whereas R stands for reduce. Okay, so when we read a non-terminal, when you read a terminal, this is nothing but a shift operation. We are shifting the one state. We are shifting from one state to the another state. So in the I0, after reading the small letter A, it is it is moving to I3. Means under A we should write I3. Instead of I3 we will write S3. Means shift 3, shifting to state 3. Now if you see here, the terminal, reading the terminal from I0, from I0, reading the terminal B, we are moving to I4. Okay, so under B we should write shift 4. Okay, so I0 is completed. From I0 there are 4 edges are there. For that corresponding 4 values we got in the table. Now coming to the state 1, which is I1. Now if you see here, I1 contains the final item. If the dot appears in the rightmost position, this is called final item. And also this is very important that it is an augmented production. The dot appears after the start symbol. Means I have read completely the input. I have read the input completely and reaches the end of the input. That means we should write dollar. As we have reached the end of the input, under the dollar, from the first state I have reached, that's why I write down except. Okay, for this grammar. As I have reached the end of the start symbol, means I have successfully read the input, and I need to, when I successfully read the input, that doesn't mean that, that means that the input is successfully read. Okay, now I2. Now coming to I2, again there are 3 edges are leaving from here. Okay, 3 edges. From I2, upon reading capital A symbol, I am moving to I5. So under A, you should write 5. You should write 5. One more symbol, that is small a. I am moving to I3. When it is a terminal, I should treat this as a shift operation. Shift to I3. So under A, from I2 to moving to I3, that is shift 3. One more is also there, that is from here to small b. I am moving to I4. This is also a terminal. So S4. Under small b, I should write S4. Okay. So I2, as we are having 3 edges leaving, having the 3 edges leaving, we got 3 different values. Now coming to I3. Upon reading the capital A symbol, I am moving to I6. So write down the 6 under capital A. Okay. Now for small a, reading the small a, I am still stays in the I3 only. So write down under small a, write down S3. Okay, write down S3. Now small b, reading the small b, I am moving from I3 to I4, shifting from I3 to I4 for the terminal B. So again S4. I3 is completed. Okay. Coming to I4. Like we have seen in the I1, it is also contains a final item. That is, A implies B dot. When the dot appears in the rightmost position, that is nothing but a final item. So this is nothing but a reduce. As I have told you before, when I read reach the last position, I can reduce to the left hand symbol. That is AA. After reaching the last position, AA can be reduced to yes. This is nothing but reduce. That's why this is called shift reduce parser. Okay. Now A implies B dot. This is a final item. So B can be reduced to A. Because I have reached the end of the input. So before that, let us name the productions. Let us number the productions. S implies A implies small a, capital A implies small b. I am giving the numbers to these productions. This is 1, 2 and 3. Okay. Now here the final item is A implies B dot. That nothing but A implies B, which is a production 3. I have given the number 3. So I can reduce the B to A. So this represents R3. Okay. So R is nothing but reducing, and 3 is nothing but the production number 3. Okay. So whenever the state 4 contains a final item, I should fill this entire row with R3. Reduce the production 3, which is A implies B to A. Okay. R3 and R3. Total row I should fill with R3. Now see I5. I5 again contains a final item. S implies AA dot. Nothing but a final item. Now when you see here, S implies AA, which is the first production. So I should write the state 5 R1 and R1. R is the reduce, 1 is the production number. Don't get confused with these numbers and this number. Both are different. when it comes to the reduce moves, the production numbers I should write here. Here the numbers are nothing but states. Okay, don't get confused please. Now coming to the last state, that is I6. Again it contains a final item. A implies A dot, okay, which is the second production. Now R is a reduce, 2 is the production number, R2 and R2. Okay, so this is nothing but LR0 parsing table. It contains only 3 steps. In the step 1, I have done a closure. First I have taken the augmented grammar. I just put a dot before the S, which is a LR0 item. Because the dot followed by a non-terminal, I should add the corresponding non-terminal productions. There is one production of S, that is S implies AA. Again the dot appears before the non-terminal, I should add the corresponding productions of this non-terminal, that is A implies small a, capital A implies dot B. This is the first step. In the second step, I have applied goto. I should read one symbol after the another, nothing but moving the dot from one position to the next position. These are the states. This is the DFD, data flow diagram, which I got in the second step. So based on these two steps, I got this LR0 parsing table. So if you observe here, as I have told you before only, the four parsers have same algorithm. Means step 1 and step 2 are same. Only they differ with constructing the parsing table only. So in the SLR1 parser also, that is simple LR, SLR1 parser also, step 1 and step 2 are same, like LR0. Only step 3 is different, that we are going to see. Okay. Now we will see how to construct SLR1 parsing table. As I have told you, the first two steps are same. That is, step 1 is closure, step 2 is goto, are same. Only the construction is different between LR0 parsing table and SLR1 parsing table. So this is the LR0 parsing table which we got. Okay. So if you observe here, the shift moves and the goto moves are same for LR0 and SLR1. That's why I have written like this. Okay, the shift moves and the goto moves of LR0 and SLR1 both are same. So how we got this? I have already explained how this S3, S4, 2, 1, 5 I got already have explained. So in SLR also same thing you have to write here. It only differs, SLR1 only differs with LR1 with respect to the reduce moves. Here if you observe here, the reduce moves are filled the entire row. In LR0 parsing table, the reduce moves are filled in entire row. But instead what we do is, so R3 is nothing but it is a production 3. Okay, R1 is nothing but production 1. Now in SLR1 what we do is, instead of filled the entire row with the reduce moves, we only filled the reduce moves under the symbol of follow of the left hand side non-terminal. Okay, for example, this is R3, right? So this is the third production, which is nothing but R3. I4 is a state. Which contains the final item. So R3 I have filled. But instead of filled is completely, I should fill only under the symbols of follow of A. Okay. So before we understand that, let us try to find out follow of A. First and follow. first and follow of A. What is the first of A? If you understand this production, if you understand this grammar, what is the first of A? Small a and small b. Okay, small a comma small b. What is follow of A? You have to check wherever the capital A is appears on the right hand side. Okay, so the capital A is appearing here, here and here. Now if you see after the capital A, what is following? Again capital A only. So the follow of A is nothing but first of A. Follow of A is nothing but first of A. What is first of A? A comma B. A comma B. This is not the end. Again the A appears here. A appears here. As the A is the last symbol, nothing is following. So as a rule, the follow of the last symbol, which is A, is nothing but follow of S. Follow of A is nothing but follow of S. What is follow of S? Nothing but dollar. The start symbol, follow of the start symbol always dollar, because start symbol is a complete entire input. The end of the input is nothing but a dollar. So follow of A is nothing but follow of S. So follow of S is dollar. Okay. A is also appears here, which is the last symbol. Follow of A is nothing but follow of A. So follow of A is AB dollar. Okay. Now coming to our parsing table. I4 is nothing but it is a final state. A implies B dot. A implies B dot, which is the third production, nothing but R3. Okay, nothing but R3. So where should I keep this R3? This R3 in the SLR1 table, I should not keep in the entire row. Instead, I should keep only under the follow of A. So what is the follow of A? A, B and dollar. Of course, it is again filled it. But what is the rule is? I should write this reduce moves only under the follow of A. That is A, B, dollar. A, B and dollar. Okay. When it comes to the fifth one, the reduce move, when it comes to the fifth fifth state, S implies A dash, which is the first production. I5 contains a final item, S implies AA, which is first production, that is R1. Now I should keep R1 in the SLR1 table under the follow of S. Only. Follow of S is nothing but dollar only. So I should keep R1 under the dollar. But in this LR0 items, if you see, R1 is filled entire row, but here I have written only under the dollar. Okay. Now coming to the last one, that is I6. Here the production is A implies A dot, right? Which is the second production. A implies AA, that is second production, which is nothing but R2. So R2 is filled entire row in the LR0 parsing table. Whereas in SLR1, I should keep only under the follow of A, that is AB dollar. Of course, here also it is filled an entire row, but the rule in SLR1 is we should write the reduce moves only under the follow of left hand side symbols. So this is SLR1 parsing table. If you observe the both tables, here the reduce moves are reduced. Somehow we have reduced. Okay, this will reduce the hectic of finding the errors in the grammar. Okay, so this is only the difference between SLR1 and LR0, only the construction of the parsing table. Okay, this is SLR1 parsing table.